Okay, let's dive right in and crack one of the most common and honestly one of the most feared types of questions in GCSE chemistry. By the end of this, you're going to know exactly how to lock in every single one of those precious marks.
We've all been there, right? You see that big 6-mark question and your mind just goes blank. But here's the thing. It's actually a massive opportunity to really boost your grade. So we're going to break one down and pull back the curtain on what the examiners are really looking for.
All right, so here it is, our target for today. An 8-mark question all about reaction rates. Now, I know that 8 markers sounds a bit scary, but honestly, don't let it fool you. We're going to tackle both parts step by step and build an answer that doesn't just pass, it's going to be perfect. Okay, first things first. Let's start with part 1. It's a nice, straightforward 2-mark explanation, but hey, every mark counts, right? And getting the wording spot on here is absolutely key. Now, the great thing is they give you the whole chemical equation right in the question. That's basically a massive hint. Just look all the way to the right at the products. You see that S with a little s next to it? Well, that S tells you everything. It means solid, and that right there is our culprit. It's the whole reason things get cloudy. So, how do we bag that first mark? It's actually super simple. The mark scheme lays it out plain as day. You just need to state that sulfur is formed. You can spell it out, SULFUR, or you can just pop down the chemical symbol S. Either one gets you the point. Easy peasy. All right, for mark number 2, you've got to describe what kind of thing this sulfur is. The absolute best, top-tier word to use here is precipitate. That's just the fancy science word for a solid that appears when you mix 2 solutions. But good news, the mark scheme is pretty flexible. You could also just say it's a solid or that it's insoluble. Any of those 3 will do the trick. Boom, 2 marks, done and dusted. Okay, deep breath. Now for the big one, the main event, the 6-mark method question. This is where having a clear, logical plan is absolutely everything. You're not just writing a shopping list here. You're showing the examiner you can think like a real scientist. The question asks you to plan a valid investigation. So what on earth does valid even mean in this context? It's simple, really. It just means your experiment has to be a fair test, one that produces reliable results. So let's build a rock-solid method together, one that hits every single point an examiner wants to see. So you want to know what a full marks method actually looks like? Let's go straight to the source. We're going to look at what the mark scheme calls indicative content. Basically, this is the examiner's secret checklist for a perfect answer. Okay, let's walk through this. First, you measure out your sodium thiosulfate and put it in a flask. Then you place that flask on a piece of paper with a cross drawn on it. Easy enough? Next, you add your acid, and this is crucial. Start the stopwatch immediately. Then you're timing how long it takes for that cross to completely vanish. After that, you do it all again, but with different concentrations. And here's the bit that so many people forget, but it's vital for top marks. You repeat each concentration and calculate an average, or a mean. That shows you're serious about reliable results. And here's a pro tip, literally pulled from the mark scheme. You might be wondering, well, how do I get all these different concentrations? You don't need a whole cupboard full of different bottles. The clever way is to take your starting solution and just dilute it with a measured amount of water. It's a really smart, practical detail to include, and it shows the examiner you really get it. But wait, we're not done yet. A good method is one thing, but to get into that top-tier 5 or 6 mark category, you have to talk about your control variables. In other words, what are you purposefully keeping the same every single time to make sure it's a truly fair test?
And here they are, the big 3. These are the ones the examiner is hunting for. You've got to keep the acid's concentration the same. You've got to keep the acid's volume the same. And this one's a bit tricky but so important. You've got to keep the total volume of the liquid in the flask the same. Why? Well, think about it. If the liquid is deeper one time, it'll take longer for the cross to disappear, right? So keeping the total volume constant makes it a fair comparison. Nailing these 3 shows you're a serious scientist.
Okay, let's zoom out and put all these pieces together. What does that dream 8 out of 8 answer actually look like on the page? Let's make a final checklist. Here we go. This is your ultimate checklist for success. First, did you nail the 2-marker by identifying the sulfur precipitate? Yep. Is your method a logical, step-by-step procedure? For sure. Did you remember to mention how you'll measure the rate with the disappearing cross? Absolutely. And did you include testing different concentrations, doing repeats, calculating a mean, and listing all those key control variables? If you've got all that, you are absolutely on track for full marks. It really is that simple. So to wrap this all up, here's a little something to think about. This whole method, this disappearing cross thing, it's a classic. The question was about concentration, but what's another factor you could change to speed up a reaction? You could use this exact same setup to test it. Have a think about that. Because when you start seeing how these core experiments can be adapted, that's when you're really starting to think like a chemist.